Welcome to class number 14 of the Leaving Cert Ordinary Level Algebra course, where you are going to start solving inequalities. An inequality involves one of these four symbols. Each symbol is read from left to right. The first symbol means is greater than. The next is greater than or equal to. Next means is less than. And the last one means is less than or equal to. Look at the number line. Numbers to the right are greater than numbers to the left. 2 is greater than -3. Positive numbers are always greater than negative numbers. Of course, if 2 is greater than -3, it follows that -3 must be less than 2. The set of natural numbers n is shown on the number line. These are whole positive numbers, or the counting numbers. Next is shown the set of integers z. These are whole numbers, both positive and negative. And finally, the set of real numbers, or, is shown, which is every single number on the number line. Inequalities. X is less than or equal to 2. This is an example of an inequality. To solve inequalities, certain rules must be obeyed. Here are the rules for inequalities. Start with a true statement and develop some rules. 8 is greater than -4. This is true. Move the -4 to the left. This is true, as 12 is greater than 0. Add 2 to both sides. This is true, as 10 is greater than -2. Subtract 2 from both sides. This is true, as 6 is greater than -6. Multiply both sides by 2. This is true, as 16 is greater than -8. Divide both sides by 2. This is true, as 4 is greater than -2. However, if you multiply both sides by -2, this is not true, as -16 is not greater than 8. You need to reverse the inequality. Change from is greater than to is less than to make it true. Divide both sides by -2. This is not true, as -4 is not greater than 2. You need to reverse the inequality. Change from is greater than to is less than to make it true. So in conclusion, you can do the same operation to inequalities as you do to equations, except when you multiply or divide by a negative number, you must reverse the inequality. Example 1. Solve 5 minus x is less than or equal to 2 plus 2x for x an element of n. Illustrate the solution set on a number line. Move the x's to the left and the numbers to the right. Divide both sides by -3. Remember to reverse the inequality. The solution is x is greater than or equal to 1. N is the set of whole positive numbers. Mark in all the numbers greater than and including 1 on the number line. Example 2. Find the range of values of x for which 3 minus 5x is greater than -9 minus 3x for x an element of OR. Illustrate the solution set on a number line. Move the x's to the left and the numbers to the right. Add like terms on each side. Divide both sides by -2. Remember to reverse the inequality. As x is an element of OR, the solution contains all of the values on the number line, less than 6, but not including 6. Notice how this is illustrated on the number line. That's the end of the class. Have a look at the demonstration examples, and when you think you are ready, do the exercise worksheet.